Hey, there it is. Right. So I think there's a nice contrast. We're in a clearly newly built building. So I'll show you something that is a little bit broken. And what I want to talk to you this morning about is technical neglect. You'll know it when you see it, or rather you won't. Neglect is a thing that doesn't happen. It's a thing that's hard to see. And what I want to talk about is the way that we reason about our code and, more importantly, about its problems. So my name's Kevlin Henney. I'm an independent consultant, trainer. I have a bunch of social contact details. I've given up just even trying to list them or even walk through the list. These days we are experiencing a fragmentation of social media. So you can mostly find me anywhere. But what I want to talk about is a small issue that we have. The confusion between cause and effect. Many people talk about, they use the phrase, technical debt. We have a technical debt problem. I'm not necessarily going to argue with teams on that when they say we have a technical debt problem, but that's not really the problem. The problem is not that you have technical debt, and I'm going to clarify, technical debt does not just mean bad code. The problem that you are actually experiencing, if you talk to a team one day and they say, yeah, we've got a technical debt problem. You come back 6 months later, we've got a technical debt problem. You come back next year, we've got a technical debt problem. You know that's not your problem. Your problem is technical neglect. Because we have to ask the question, where did the technical debt come from? It did not appear by magic. It was created in some way, or it was caused in some way. If we have unmanaged technical debt and we keep complaining about it, we are experiencing an effect. But that's not necessarily the cause. So let's just think about this from a different point of view. You are in a boat. You are out on the water. There's holes in the boat. Things are getting wet, and it looks like everything's going to sink. What do you do? There are a couple of things. Well, let's ignore the whole swim away thing. One of the things you might be looking at is like, yeah, I could empty the boat of water. The other thing that you can do, and also do, is you can stop the water coming in. Developers focus on this. You need to stop the water coming in. And I really noticed this a few years ago when dealing with a team. Hey, we got a whole load of legacy code. What are some techniques we can use to address it? So, we ran some workshops. That was good. They made an impression on their legacy code. They emptied out some of the water. I spoke to them again sometime later. Oh yeah, we've got a legacy code problem again. It turns out one of the things that people are not very good at is asking the question, how did we create this situation? One of the things we need to learn is how to stop creating the problem that we are experiencing. So when a team says we have a technical debt problem, you need the origin story. What is the cause of that technical debt? Now, it's interesting because we have a challenge with language to talk about what it is that we work on. Software is a very abstract thing. The way I'd like to describe it is that software is not kickable. It's not physical. You can't kick it when you're frustrated. It is a very abstract concept. We can choose to present and visualize it in many different ways. And people have talked about this problem when we have problems with the code for many decades, and only really recently have we started converging on the language across the industry. But quote Meyer Lehman here, who wrote this in 1980, and actually it's based on his work in the 1970s. So the idea is his observations are actually quite old. And the size of the systems that people were dealing with typically back in the 70s and 80s are quite small compared with what we deal with now. But his observation was quite key. As an evolving program is continually changed, its complexity, reflecting deteriorating structure, increases unless work is done to maintain or reduce it. Now, I like this because he's made an explicit point. Even if you are changing something for good, even if you are changing something to add a feature, there is inevitably going to be some other consequence that you will have to address. You've got to put extra work in. That's part of the cost of ownership. But there's another thing here that I think is interesting. Work is done to maintain or reduce it. What he's talking about, you're probably looking at that quote going, oh, refactoring. That's what he's talking about. 1980, the term refactoring did not exist. It was not due to exist until the end of the 1980s. But he used the word maintain. What he's actually talking about is maintenance. Now, in software, we've ended up using maintenance. I'm not going to say incorrectly. No, I am going to say incorrectly. It's not the right metaphor. Maintenance, when most people talk about software maintenance, they're talking about bug fixing. They are talking about continued development. So sometimes you will get this idea, oh, the first version of the product was developed over here in this country, and then we've sent it to other country for maintenance. What actually happens during maintenance? More software development. I call that software development. It's not maintenance. Maintenance as a metaphor describes what happens to something as we use it and it experiences wear and tear. It starts breaking down. My washing machine needs maintenance. The more you use it, the more you need to maintain it. Now, software doesn't suffer physical usage, but it does suffer a usage and interaction from the point of view of developers who get in there and effectively disturb it, normally for good reason. He is talking about the idea of maintenance. A more appropriate use of the maintenance metaphor is something we don't use. Software needs maintenance. If you are going to add features, what are you doing to maintain the software, the code? So this takes us into a territory of language. Now, I like words, I like language. I have a copy of the Oxford English Dictionary on my laptop. The Oxford English Dictionary, I will just tell you, if you are after a dictionary that helps you use English, this is not the dictionary you want. This is a terrible, terrible dictionary if you want to find out how to use English. That's not the purpose of this dictionary. That's a usage dictionary. It tells you the top entry in a usage dictionary is the most popular usage. This is a dictionary of etymology. It tells you the history of the word. And it goes back 1,000 years if it needs to. So, yeah, this is for word geeks. But it's one of my main sources. So we're talking about metaphor here. The figure of speech in which a name or descriptive term is transferred to some object different from but analogous to that which it is properly applicable. The key word here is transfer. It actually comes from the Greek metaphora, literally meaning to transfer. We are taking an idea and we are transferring it to something that's not truly, literally what it's about. In this book that Frank Bushman and Doug Schmidt and I co-authored, I guess it's over 15 years ago now, Poser 5, we talked about a number of things, and particularly the abstractness of software, how we use language, even how we talk about it from semiotically. The aphysical and invisible domain of software is more about metaphor than matter. And we see this all the time. I mean, this is what you work with. Okay? This is the matter. This is the hardware. This is the physical stuff. You're a software person, so you don't like to think about this. Maybe you like to think about the ones and the zeros. No, you probably don't think about that either. Maybe the assembler. Not these days. That's not a thing. We sometimes look at it, but very few people write it. It turns out with RISC-based architectures and instruction pipelining, it's very difficult for a human being to write this successfully. So we tend to work at the level of code. That is our main point of contact and thinking with stuff. By this point, we are very, very far removed from the machine. And we start populating our code with language, with meaning. I mean, we could call everything I and J and X and Y. Please don't. But we don't. We choose language. We choose a form of communication. Software is expressed, when we're expressing it through code, we have very few tools at our disposal. We have spacing. We have punctuation. We have words. That's it. That is everything that you have to express everything that you want to express. But notice you're moving away from the idea that machine is long gone. You are not thinking about the machine. But I can go further than this. I can represent something visually. And let's be absolutely clear. What I've represented there, it does not look like that in a machine. We use the whiteboard. We use various notations. It doesn't look like that. We are choosing a representation to make it easier for us. We can go even further and actually not just give a structural view, but a temporal view, which is an even higher level one in the sense of actually talking about how this flows over time. So it's not just a spatial structure, it's a temporal structure, a time-based structure. And we give it the name stack, one of the oldest data structures that we find. And stack is obviously fundamental to everything that you program, in the sense that even if you don't care about it, you have a call stack. But what is a stack? Well, that's a stack. All that code, that's not a stack. None of that is a stack. We have borrowed a word from the real world to say, I want you to think about this arrangement of things as if it were a stack. And it comes with its own vocabulary. It has a top. It has a depth. I can pop something off the top, or I can push something on the top. So we have a language, a system of language, and it helps us understand it. So quite literally, as described in this book, published in 1980, metaphors we live by, and we can think of this as metaphors we code by. Lakoff and Johnson talked about this. They kind of shifted how people perceived metaphor as something simply to do with poetry, as something fundamental to language. The essence of metaphor is understanding and experiencing one kind of thing in terms of another. Okay, so what makes a good metaphor? Because technical debt is a metaphor. Even legacy is a metaphor. I wrote a piece a couple of years back where I explored this question with reference to technical debt. But importantly, I also want to explore this question of metaphor. Because sometimes people say, oh, yeah, that metaphor, it's not good, or that metaphor is broken, or that's a good metaphor. What do we mean by that? So to be considered good, a metaphor has to offer a number of points of useful correspondence with what is being described. So in other words, there has to be enough there that when I use the metaphor, you go, oh yeah, I see that. The whole idea of transfer is I'm normally trying to describe something that is complex or abstract or unfamiliar in terms of something that is familiar. Yeah? Oh, you see this thing that you don't understand. Well, here's a thing you do understand, and I want you to understand this thing in terms of it. Transfer. So to be good, there has to be enough transferred. Okay. Another quality of a good metaphor is it should not have too many obvious points of conflict. Now, this is important because sometimes people get very hung up on where a metaphor is not perfect. People say, oh, that's not a perfect metaphor. Sometimes we see people sort of debating software engineering, software architecture, software craft. These are all, in one sense, metaphors. And people say, oh, that's not a good metaphor because of one particular reason. It's not a perfect metaphor, people will complain. There's no such thing as a perfect metaphor. Okay? If it's perfect, then it's not a metaphor. Yeah? If something exactly describes something else, then it is that thing. So it's not a metaphor anymore. So we should always keep that one in mind. We can find better metaphors, but we will never find the perfect metaphor. The third quality of a metaphor that makes it effective is familiarity to its audience. If I want to convey an idea that is abstract or complex or unfamiliar to you, and I say, how to think about this is in terms of this, and you don't know what this is, then that's, from your point of view, not a good metaphor. Okay? So, let's pick on this one. This is from an article by, it's a blog post from Steve Freeman a few years back. It's currently not live. You have to kind of go through the web archive to find it. And it's based on an observation from Chris Matz. Now, Chris and Steve both work a lot in financial software. And they made this observation. Bad code isn't technical debt, it's an unhedged call option. I disagree with the first part. I'll explain why in a moment. Bad code isn't technical. Yeah, it is. That might not be the best way to think about it, but it certainly is. It's an unhedged call option. There's a problem with this, or there's a benefit. Who knows what an unhedged call option is? Yeah, you see the problem? That doesn't mean it's a bad metaphor. It means it has not found its audience. In fact, there was another wonderful observation from a different article. For people in fintech, this is a really interesting analogy. If you are in the finance space, then you'll go, oh yeah, I see. If you're not, you go to the internet and you say, okay, unhedged call options. I now need to learn about unhedged call options. I need to learn, therefore, what hedging is and what a call option is and what the consequences of that. Before you know it, it's 3 o'clock in the morning and you have found the causes of most financial crises over the last 2 decades. And you've completely forgotten about technical debt. The point here is it has to be suitable for the audience. It's not a good metaphor in that context if the audience doesn't get it. So, let's talk about another term, legacy. I think legacy is fascinating because normally we talk about legacy in positive terms. Designating software or hardware which, although outdated or limiting, is an integral part of a computer system and difficult to replace. Also in extended use. Okay, so here's an interesting thing. For me, this is very interesting. Checking this one out. The first point of usage is 1989. Now, for some of you, you're going like, well, that's like when the dinosaurs were around. Anything that existed before you were born is like, way, way back. But for me, this feels quite late. I mean, we've been developing software as an industry for quite a long time by this point. The world was already beginning to run on software. 1989 feels really late to be coining this term. Interestingly enough, this is also the year in which the term refactoring is around this time was coined. Now, while we're talking about legacy code, we have to worry about the creation of legacy code. It's about the origin story. And of course, this is 2023. I've just read that the Collins Dictionary has chosen as its word of the year, you may be familiar with this, you're going to be flooded with them over the next few weeks. There will be various announcements in the English-speaking world about the word of the year. Collins Dictionary has announced that AI is the word of the year. And obviously, as I'm doing a talk, I have to talk about AI. Here's my thoughts on AI and legacy code. The practical consequences of using large language models to generate code is that many developers will find they have unwittingly moved themselves into a role they were probably trying to avoid. They have automated the creation of legacy code and have redefined their role as debugging and fixing such code. A lot of people are going like, oh, this is great, this is fantastic, I've got so much productivity. If you're using ChatGPT, can I just ask you to do one thing? Please write tests. I have these occasionally interesting interactions with ChatGPT. Hey, tell me about this. And it comes out confidently. I mean, ChatGPT is basically it's a people-pleasing, knowledgeable sociopath. And it will give you an answer and say, this will work. Test it. The amount of times it's given me code that does not actually, I mean, it looks plausible, but it doesn't actually work. Sometimes doesn't even compile. So please do that. But I want to remind you of one of the practical definitions. I've run many workshops where I ask people, you tell me what legacy code is. What is it that you mean by it? It turns out different people mean different things by it. I'm not going to say there's any one right answer. You find there's normally a space of variation. And normally you want to understand what somebody else is saying. Sometimes legacy means, hey, we've had this system a long time. It just refers to the age. Sometimes legacy is a judgment of quality. Sometimes it's describing something about the technology. Oh, this is legacy because it depends on something that is no longer supported. Sometimes describing something as legacy is a statement of knowledge, or to be precise, lack of knowledge. This is legacy because the people who wrote it have left the building. We don't have any idea what it does or why. And one of the most common definitions that I get is legacy is code written by somebody else. I present you with ChatGPT. That's the thing. You need to be really careful with this stuff, because otherwise what you've done is you've given the fun piece of work to a machine, and now what your job is to try and fix it, because it was written by somebody else and you don't know what they were thinking. And if you ask why, it will tell you an answer that may not be true but will sound good. So be very careful. Anyway, here's a classic legacy system that we have in the UK. It's an old computer. We're not entirely sure why they built it. Yeah, they've left the building. But it does work twice a year. And nobody dares change it. But what other terms do we use when we're trying to describe the challenges we have with code that was written by somebody else, code that we struggle to work with, code that we might describe as messy? We might call it legacy. We might call it spaghetti. That's not really a metaphor, it is an analogy. Spaghetti is about the structure. It tries to show that it's tangled, but it doesn't suggest that when you say spaghetti code, it doesn't suggest that it's bad. I mean, who likes spaghetti? I love spaghetti. I think it's great. If you tell me my code is like spaghetti, that's yum. I'm in. And people have created loads of pasta-based approaches. So you don't want spaghetti, you want lasagna, you want a layered architecture. Or you want ravioli. These days people think ravioli is microservices. You go back a few years, it was services. What I find funny is, having been around, is, let me show you the relative scale. This is a microservice. This is a service as it was 15 years ago. See, micro means bigger. Go back a few more years. Oh yeah, ravioli means components. Go back a few more years. Ravioli means objects. Each generation discovers its own pasta. But obviously, that doesn't make spaghetti bad. It's just a description, it's a structural description. Then we get into the metaphor territory. This is quite interesting. We use terms like code rot, software decay. I'll come back to entropy in a moment. This kind of gives you a sense of something that degrades with time. This feels not a bad metaphor, except for one small problem. These happen, rot and decay in the real world happen without your involvement. If I leave something that is biological, like yogurt, and I leave it in my fridge for a few weeks, I will have created new life forms. If I leave an apple for too long, it will rot. It doesn't need any input from me. There is a natural biological process that continues without any intervention whatsoever. If you leave a piece of code and don't touch it for 10 years, there is no intrinsic rotting or decaying. You don't come back and go, okay, let's go and have a look at that old Subversion repo. Oh my goodness, the curly brackets have fallen off the code. We left it so long. The semicolons are just beginning to fade. Man, some of my variable names, I can't even see them anymore. They're covered in decay. That's not a thing. So the problem here is that there's a sense of agency. How did that happen? Entropy is an interesting one, because it actually gets closer to Meyer Lehman's observation about the idea that entropy is a measure of disorder. It's a physics concept. It's also an information theory concept. But it's a physics concept. Entropy is the measure of disorder of a system. Second law of thermodynamics tells us that a closed system, disorder will increase, entropy will increase over time, unless you put work into the system. Now you see, that works quite nicely. It actually aligns very nicely. Oh yeah, you have to put work into the system to make it more ordered. That feels right from our point of view. There is, however, a problem with this metaphor. It's to do with its applicability. I found that I stumbled across this metaphor pretty much the first job that I was working after university. And I think half of the developers at that company had studied physics, myself included. So for us, entropy was, yeah, you say, oh, this code base has entropy, and people go, yeah, I understand what you mean. Yeah. The problem is, if you don't understand what entropy is, it's not a good metaphor, because then I have to explain the second law of thermodynamics and things to you to then understand the code. You probably have a better understanding of code than you do of physics. So there's a weakness there, and it's to do with audience. It's not intrinsic to the metaphor. Technical debt, well, we know this one. Unhedged call option, we've just seen that one. Housework. Oh, that's interesting. Yeah, we'll come back to that. So where did this term technical debt come from? Originated with Ward Cunningham. Strictly speaking, Ward did not use the term technical debt, he used the term debt. So I always refer to it as the debt metaphor. But it was increasingly used throughout the 1990s. Martin Fowler helped popularize it. And from about the early 2000s, it became the term that people started to use, to the point now that people can't imagine that we never used it. And Martin says, acknowledges it's a metaphor. Technical debt is a wonderful metaphor developed by Ward Cunningham. In this metaphor, doing things the quick and dirty way sets us up with a technical debt, which is similar to a financial debt. Now, the notion here is, during the 90s, some people were using bits of this metaphor. It wasn't popular. Quality debt was sometimes used, design debt was sometimes used, technical debt was sometimes used. But pretty much from the early 2000s, when Martin started writing about it and helped boost its signal, the term technical debt stuck. But there's a problem. It's a very subtle problem. And the problem that we've ended up with is that people think technical debt is necessarily a bad thing. When they talk about technical debt, they're going, oh, technical debt, it's bad. In their head, technical debt is a bad thing. Where did that idea come from? It came from subtle use of language. I mean, certainly many people associate debt as not being a positive thing. So you already have it in your head. It's already out there in the world. But Martin kind of helped reinforce it a little bit by using the term quick and dirty. That's not a positive thing. Okay? When we say quick and dirty, we're not saying great things about something. We're kind of excusing ourselves. Oh yeah, I got it to work, but it's a bit of a quick and dirty solution. That's not saying it is the most elegant, beautiful thing I have ever written. Quick and dirty is not praise. It's kind of like, yeah, it's an apology. It's an acknowledgement that it could be better. Immediately we're saying something effectively, it's bad. That's kind of where this came from. So people started to associate that, the badness with technical debt. That comes to dominate in people's minds. So when you say, oh yeah, we have technical debt in our code base, I go, yeah. Yeah, but Kevlin, that's a bad thing. Well, I don't know, is it? Because let's look at what Ward actually said back in 1992. Shipping first-time code is like going into debt. A little debt speeds development so long as it is paid back promptly with a rewrite. He was saying something beneficial. He was using debt as the idea of achieving a short-term advantage. Let's imagine we're taking on a new technology. We're adding something new to our stack. Do we know how to use this framework? Do we know how to use this tool? No, we don't, because it's new. Does that mean we're going to do the best work? Probably not, but we're going to do something. So let's just try it. So we know that there will likely be some kind of debt that we're going to have to pay. We'll come back to it. That's okay. We know it's not going to be good. It's not intentionally quick and dirty. Sometimes it is. Sometimes there's the idea of we need to get this out to get some kind of benefit or feedback from the customer. We know it could be better. We know we're missing features. but let's actually get that feedback. It allows us to trade off in time. There are a lot of reasons you intentionally take on debt to get a benefit now versus some point in the future. And that's the idea. In fact, I would actually argue that what Ward is actually describing is subtly different. It's related, but it's a borrowing metaphor. It's not a debt metaphor. The idea of debt is that you are borrowing, and the idea of borrowing is that you pay it back. When you borrow something, there's two sides to it. There is the taking, there is the repayment. People are really good at the first bit, not so good at the repayment. That's why I tend to reframe it. It's a borrowing debt. Who are you borrowing from? You're borrowing from your future self. You're borrowing from your future work. You're borrowing from your future opportunities. Borrowing makes it a little more concrete. But even when we read Ward, we can see that that's in there. The danger occurs when the debt is not repaid. Every minute spent on not quite right code counts as interest on that debt. So it's not intrinsically bad. Now, of course, if we end up with bad practice, and again, how does bad practice happen? It's not from bad people. Let's always be very clear about that. You're not a bad person if you write code that you come back to next year and it sucks. Guess what? You learned something. Awesome. Let's be very clear. You are always working with incomplete knowledge. That is what it is to be human. That is what it is to be a software developer. The knowledge you need to do the best job on the thing you are working on today, the knowledge you need is in the future. But you can still make progress. You just need to acknowledge that in the future, you will make that recognition and go, we can do this. Now I can maintain it to a better standard because I have knowledge that I simply didn't have in the past. I did the best I could in the past, but the knowledge, the experience was missing. So there's an inevitability to running up debt that again is also appealing because everybody has an experience of debt and borrowing. So that's why there's power in the metaphor, but it's not always bad. So let's be very careful here. I made this observation. Although we know that by definition no metaphor is perfect, there are two common ways in which the metaphor is misapplied. The one I commonly see is, we've already mentioned, assuming it always means bad. The other is when people say, technical debt is financial debt. And there are even tools, which I'm not going to mention, but you might know them. There are tools that will look over your code base and say, here is how much technical debt you have, and it will give you a financial figure. Your code base has 153,422 euros and 16 cents of technical debt. It will give you a precise number. Scientifically speaking, there is a term that we can use to describe this result. It's bollocks. If you wanted me to translate that from British English to American English, it's bullshit. It's bad science. It's not even science. It's just fiction. And as somebody who writes fiction, I enjoy good fiction. But I also know what it is. That's not good fiction. This is a totally made-up number. The whole point of a metaphor, technical debt is not financial debt. It is like. It allows us to borrow the language. It allows us to understand that there is an interest rate. In fact, that's the whole point. And this is where we get back to the question of effect and cause. For many people, when they say, we got this technical debt, it didn't appear magically. But they're missing the cause, but they're also missing something else. They're missing an extra word. The problem that most people have is not technical debt. The problem that most people have or are experiencing, the effect they are experiencing is unmanaged technical debt. Because honestly, if it's managed, we're good. Hey, we have a debt. Oh, wow, that sounds really dangerous. Oh, yeah, no, we're totally repaying it. We have a structure where each developer does this in their week, or each month we do this. In our code reviews and our pairing and our ensemble sessions, we do this. Oh, you sound like you've got it under control. Totally. It's managed. We account for it and we repay it. Having debt is not intrinsically bad. My wife and I had a debt. It's called a mortgage. Guess what we got? A house. Awesome. It turns out that that's the benefit we're looking at. And it was a structured, managed debt. We understood the terms and conditions. We had total control over it according to the terms and conditions. and we understood the benefit as well as the liability that we were getting. Assets versus liabilities. The language is very clear. We can do the same with code. The problem people are complaining of is unmanaged technical debt. And what does unmanaged technical debt lead to? Well, quite a lot of things. People don't like working on something that they know could be better. People don't like thinking, I am wasting my time on this code. Or it takes so much work to do so little benefit. People don't like that as a daily experience. Staff retention is a problem. Security is also another one. I found recently that it's very easy to motivate people into thinking about this by using the word security. People care a lot. People care a lot more about security than they used to. One of the things I like watching is films from the 1980s and 1990s where somebody types in a password and you've got somebody trying to hack the password. And they kind of look around the person's office, and there's a picture of their dog, and the dog's name is Fido. Yeah, let's type in Fido. And suddenly they've unlocked the account. Because that's what passwords used to be like. They were that simple. These days, security is a big concern, because we have connected everything together. Back then, not everything was connected together. So now you scare people by saying, tell me about security. You even have companies appointing the security architect, the security SAR, and so on. It's such a big deal. So these days, one of the ways to motivate management of technical debt, focus on quality of design and intrinsic code quality, is by saying, security. Because when you say unmanaged technical debt, what you're doing is you're saying, there's a part of our code that we don't really understand and we don't have full control of. So tell me about your security. Our system's totally secure, but you just told me you don't know what this does. That's not secure. I can't make that claim. I don't know what this depends on. If you don't know your dependencies, you can't make claims about security. Okay? And so on. So we have a number of things here. Compliance, your bugs, your overall development. This is much harder. Changes, technology, everything. So that's the message. The message here is not simply a measure of the specific work needed to repay the debt. It is the additional time, effort added to all the past, present, and future work that comes from having the debt in the first place. It's the cost of the interest. It's not a repayment cost. It's the cost of ownership. How much extra work does this add to your day? So let's talk about housework. Lovely observation from Yvonne Lamb. My theory of tech debt is that housework is the correct metaphor for the thing we call tech debt. But we can't use it because tech debt has been made up of people who don't do housework or manage housework being done. Now that's the interesting thing. Housework, that's a maintenance thing. The very act of living in your own home creates mess. You get up in the morning, the bed is now a mess. Was that your goal in the morning? My goal today is I'm going to get up and make a mess. I mean, if you have young children, yes, that is their goal. But that's not your goal. Your goal is to get up. As a side effect of getting up, your bed is now a mess. You go to the kitchen. You get yourself a coffee. You get yourself some breakfast. You've made a mess. Yeah, but you've also achieved coffee, well done, and breakfast. But notice there's a natural consequence. I went to add a feature to the code. Was it my goal that I was so focused on the feature that I missed something else that is now not quite as good as it should be, that feels like a workaround? Yeah, it's not my fault, because that's an inevitable consequence of something we call focus. Yeah, remember, and this is kind of one of the more interesting observations, we often talk about attention management and focus. Focusing on your work, being able to get in the flow of things, to have focus. What does it mean to have focus? To have focus means you are ignoring all those other things. To have focus means you have non-focus on everything else. That's why you end up doing things like, making a little bit of a mess or not having the best code that you could possibly have at that point, because you are focused on the best code at that point, or the effective code at that point. By doing that, you have disturbed, just like getting out of bed. Sure. So what do? We do additional work, housework, maintenance. We maintain the thing. In fact, we have, in the UK, we have this figure, Isabella Beeton. She wrote a book, the Book of Household Management, in the 19th century, the middle of the 19th century. That book was still in print in the middle of the 20th century. And Mrs. Beeton's cookbook was the standard book that when you went to university, up until the 1960s, 1970s, people would normally have a copy of Mrs. Beeton's cookbook so that they could actually feed themselves at university. But she looked at what does it take to run a household, in particular the kitchen. She told us about the timing. There is no work like early work. When you're building a feature, if you've got this kind of like accidental complexity that you've introduced into the code, because you will introduce accidental complexity as a side effect, you may clean it up immediately, or you may not notice it, and it's only later that you experience it. But as she says, there is no work like early work. When people say, Kevlin, when should we do all of this stuff? There you go. Mrs. Beeton has the answer. Clear as you go. Muddle makes more muddle. If you leave stuff, that stuff will get in your way the next time you're doing something. You now have to work around it or push harder onto it. Not to wash plates and dishes soon after using makes more work. Isabella Beeton was a contemporary of Charles Babbage and Ada Lovelace, people who are associated with the dawn of computing. I think Isabella Beeton was one of the greatest Victorian programmers we have ever seen, but she cleverly disguised her advice on software as a book of household management, the ultimate metaphor. So we're talking about maintenance. Now let's kind of draw this one to a close, because maintenance is an action. Maintenance is a thing that you do. The problem that we often experience is inaction, a thing that we don't do. That is why it is so hard to see technical neglect, because you're not looking for a thing that people are doing, it's an absence of a thing. So neglect, quite literally, is this observation, want of attention to what ought to be done, the fact of leaving something undone or unattended to, negligence. The issue is that we're not looking for something that people are doing. It is something that people are not doing, that teams are not doing. That's why it's very hard to see. The neglect, and let me be very, very clear, I'm not saying neglect is a better metaphor than technical debt. I'm saying that neglect is what leads to the unmanaged technical debt. And it's hard to observe this because it's a thing that does not happen. It's easy to see things that happen. It's an inaction, not an action. So let me close with a thought from John Seddon. John Seddon's a kind of systems thinker. He's based in the UK. I saw him speak many years ago at a Lean Agile conference, Lean Kanban conference, about 2008. He's not, as I say, he's not a software guy. He's done work in the UK on the NHS. He has a number of observations about systems, and he had this useful framework for understanding the nature of our work. And naturally, he kind of frames it in much more economic terms. Supply and demand type language. And he breaks down demand into two types. So what do I mean by demand? Let me make this very personal and real. You are sitting there in front of some source code. Why are you there? What is it that you are doing? What is the demand for your work? What is it that causes you to be doing what it is that you are doing at the moment? And he breaks it into two. Of course, we could break it into many different categories, but let's just stick with two because it keeps things simple. Value demand represents the demands customers make for the things they want, things that are of value to them. Value demand is the addition, I'm working on a new feature that somebody said they wanted. Okay, cool. That's value demand. What is failure demand, though? Failure demand's interesting. Failure demand is created by the organization not working properly. That's the big picture view. Let's go into the detail. Failure demand is demand caused by a failure to do something or do something right. A failure to do something, an absence of a thing. Failure demand is the work that we do because the world is not perfect. The world will never be perfect, but it can certainly be less imperfect. Fixing a bug. I am fixing a bug. That's failure demand. Does it actually add value to something? Well, certainly the customer probably doesn't want the bug. I'm pretty sure of that. But that is extra work that does not genuinely bring value to the system. But we also have it in other ways. That's a very obvious one, but in other ways. If you sit there looking at the code, struggling to understand it, that's failure demand. Your time is being spent because you don't understand the code. The code is not as understandable as it should be. If you are sitting there looking at a class that is so large that it has its own gravitational field, it is thousands upon thousands of lines long. The time you spend trying to negotiate that code, that's failure demand. You spend a lot of time not making any progress. Failure demand is absolutely everywhere. I'm going to say this, I don't have the numbers for this. Please don't quote me on this unless you say Kevlin has an opinion. This is not backed up by science, just an observation particularly from one company that I worked with. I would estimate that company, on a good day, out of an 8-hour working day, a developer would spend 7 hours on failure demand. That's on a good day. On average, it could be actually worse. The question is, what am I working on? Why does my work exist? And failure demand, which is in part a response to technical neglect as well as other things, is that reason. I remember a friend of mine coming back. I worked with him. He went off to Silicon Valley. He worked for a startup. Came back to the UK. We went out for dinner. And he said, "Oh, Kevlin, in the last year, we've doubled the size of the software development department." He said, "We've gone from 30 people to 60 people." I said, "Oh, that's pretty cool." But the question is, Ray, what are those new 30 people doing? Are the 30 people you recruited in the last year, are they fixing the mess of the first 30 people? Or are they doing value? Yeah? What we find is that most organizations, when they scale for the wrong reasons. They scale to manage their failure demand. They scale to manage the problem of the debt that they have created, unwittingly, in most cases, people don't do it intentionally, through this idea of technical neglect. So, bring it to a close. Quote from Annie Dillard, author Annie Dillard: "How we spend our days is, of course, how we spend our lives." The reason I'm focusing on this one is the reminder that the things that we do on a daily basis are the things that create the systems that we work on. There's no big magic event. You can't say, "Oh, in 2 months' time, everything will be wonderful. In 2 months' time, we will do a major refactoring and repay all of that." Don't do it like that, because it will never happen. Because you will discover that 2 months' time is always in 2 months' time. In 2 months' time, it's January, and you'll be going, yeah, we'll do it in March. In March, you'll do it in May, and so on. The point is that it's mostly to do with little actions that make you feel comfortable in the space that you're in. It's about the smaller habits. Neglect is an absence of something, just a little bit more attention and awareness, the fact that you are on a learning experience as you work with your systems, you have this knowledge, the ability to just apply it even in the smallest amounts, but also collectively, is what will allow you to deal with what you perceive as a technical debt problem, but is actually an absence, a neglect. So I'm hoping that gives you something to think about as you have a coffee. Thank you very much.